Aston Martin just arrived in Bahrain with one of the most anticipated engine partnerships in Formula One, and by day 3, the car was locked inside the garage with a critical battery failure. Not a small glitch. Not a minor calibration issue. A thermal runaway risk in the heart of the Honda power unit. The AMR26 lost nearly 500 horsepower. 10 seconds per lap slower. More than 30 kilometers per hour missing on the straights. And the most alarming part? Honda did not have a corrected replacement unit on site. This is not preseason noise. This is reliability collapse before the first race even begins. While Red Bull stacked race simulations. While Ferrari refined long-run pace. Aston Martin was cutting holes in their own bodywork just to keep the engine alive. And what Honda quietly admitted behind closed doors could define whether this project survives the opening Grand Prix. If you think this is just testing drama, wait until you hear what the data actually exposed. Subscribe now. Because the reality behind the AMR26 is far more serious than anyone expected. Let's slow this down and look at what really happened on that Friday morning in Bahrain. Because this was not a routine delay. This was silence. The kind of silence that spreads tension across a paddock. Ferrari was running long stints. Red Bull was stacking data. McLaren was simulating race pace. And Aston Martin's garage doors stayed closed. Screens up. Mechanics inside. No car on track. At first, it was described as a precautionary check on the hybrid system. But internally, the alarm was much louder. Honda had detected a critical fault in the energy store at the end of the previous session. Not a loose connector. Not a software reset. A structural overheating issue inside the high-voltage battery. And here's the key detail. This battery is central to the entire philosophy of the new power unit concept. The electrical contribution is massive. Close to half of total output. Which means if the battery is unstable, the whole engine becomes compromised. Now imagine this. Bahrain heat. Repeated charge and discharge cycles. Full deployment down long straights. Aggressive energy harvesting into heavy braking zones. And the battery temperature begins to spike. Not gradually. Exponentially. Thermal runaway risk. That is the term engineers use when temperature escalation becomes uncontrollable. When safety systems are forced to cut power to prevent catastrophic failure. Honda confirmed that the safety protocol triggered automatically, which means the system detected dangerous thresholds. And here is the brutal part. They did not have a revised specification battery in Bahrain. No immediate replacement. No upgraded unit ready to swap. They had to attempt a repair inside the garage, on a high-voltage component, under strict safety measures. That is not standard preseason inconvenience. That is vulnerability. And it exposed something deeper. The simulation data from Sakhir did not match the track behavior. In the factory, cooling predictions looked stable. On track, under real airflow conditions, the thermal load was higher than expected. That means correlation is off. And when correlation fails, development becomes reactive instead of proactive. But that was only half the story. Because even if Honda solved the battery issue overnight, the AMR26 has another limitation. The packaging. This chassis is extremely tight. Compact side pods. Minimal body volume. Designed for aerodynamic efficiency. But aggressive packaging reduces cooling margin. And when the power unit runs hotter than predicted, there is no extra airflow buffer. Which explains why mechanics were seen modifying bodywork inside the garage. Opening additional vents. Creating emergency cooling exits. Every cut increases drag. Every opening reduces rear downforce. Every compromise moves the car further from its intended aerodynamic concept. So what we saw on track in the afternoon was not the real AMR26. It was a restricted version. Hybrid output limited. Short runs only. Fernando Alonso circulating for 3 or 4 laps at a time. Returning immediately to the pits. Monitoring temperatures. Resetting systems. Trying to gather basic aero data without stressing the power unit. The car was nearly 10 seconds slower than front runners during some phases. And while some fans dismissed it as sandbagging, the telemetry tells a different story. Straight line speed was dramatically lower. Clipping occurred far earlier than competitors. Energy deployment was being curtailed to protect the battery. That is not strategy. That is survival mode. And when a team enters survival mode in preseason testing, it reveals more than they would like. Because preseason is about pushing limits. Finding weaknesses. Solving them before race 1. But Aston Martin is not refining performance. They are fighting reliability. And that shifts the entire narrative. This was supposed to be the beginning of a new technical era. Instead, Bahrain has exposed a brutal mismatch between chassis ambition and power unit adaptation. And we are still only in testing. No pressure of qualifying. No pressure of race starts. No pressure of wheel-to-wheel battles. If the battery cannot handle controlled simulations, what happens over a full race distance? That is the question now hovering over Aston Martin. And the deeper we go into the data, the more uncomfortable that question becomes. Now let's talk about what this means for the drivers. Because machines fail quietly, drivers do not. Fernando Alonso did not need to say much on Friday afternoon. You could see it in the way he removed his helmet. No anger. No dramatic gestures. Just controlled frustration. He knows what limited mileage means. Less than 200 laps across 2 weeks. That is the lowest total of any full-time driver in the field. In modern Formula One, that is crippling. Preseason is not just about speed. It is about understanding tire behavior, brake balance evolution, energy management over long runs, setup direction under changing track conditions. Alonso has not had the chance to build that foundation. Instead of simulating race distance, he has been cycling through short runs, system checks, temperature monitoring. That affects confidence. That affects rhythm. And rhythm is everything before race 1. Lance Stroll felt it too. He was the first to mention a massive time loss in early comparisons. At one stage, nearly 4 seconds off competitive pace. At first, it sounded exaggerated. But once the hybrid system began clipping early, the data confirmed severe straight-line losses. More than 30 kilometers per hour down at the end of the straight. That is not aerodynamic drag alone. That is electrical power disappearing before the braking zone. And here is where the situation becomes even more uncomfortable. During low-speed acceleration phases, excessive vibrations were reported. Not minor shaking. Harmonic vibration through the drivetrain. Strong enough to stress engine mounts. Strong enough to create micro-cracks in gearbox components. When vibration reaches that level, it points toward deeper mechanical imbalance. Possibly in the crankshaft assembly. Possibly in the integration between the internal combustion engine and the motor generator unit. And that is not something solved with a software patch. That is structural engineering. So now Aston Martin faces 3 simultaneous threats. Battery overheating. Cooling limitations due to aggressive packaging. Mechanical vibration affecting reliability. And all of this is happening before the first competitive lap of the season. But there is another layer that makes this even more intense. Lawrence Stroll. He invested heavily in facilities. He recruited top engineers. He secured Honda as a long-term partner. This project was positioned as a bold reset. A new chapter. Instead, preseason testing has exposed fragility. Reports from inside the paddock suggest tension between Aston Martin leadership and Honda's technical management. Because expectations were clear. Reliability first. Performance second. Right now, neither is stable. And here is the brutal reality. If you cannot complete a race simulation in testing, your probability of finishing race 1 decreases dramatically. Testing does not exaggerate reliability issues. It reveals them. And the AMR26 has not demonstrated endurance. It has demonstrated vulnerability. Yes, there is theoretical potential. The chassis concept is ambitious, compact, aerodynamically efficient when fully sealed. But that version of the car has not been able to run safely under full power. So the team is stuck between 2 compromises. Open the bodywork and lose downforce. Or close it and risk overheating. Neither scenario wins races. Honda now has days, not months, to recalibrate energy deployment software. To improve thermal management strategies. To possibly reinforce battery casing or adjust charge cycles. Because once the season begins, development bandwidth shrinks. Points matter. Pressure increases. And reliability problems compound quickly. This is why Bahrain testing feels so significant. Because it did not just show a slow car. It exposed a mismatch between design ambition and operational reality. And if that gap is not closed immediately, the AMR26 will not be fighting for podiums. It will be fighting simply to finish. Which raises the uncomfortable question. Did Aston Martin push too aggressively with packaging before fully validating the power unit's real-world behavior? And if the answer is yes, then Bahrain was not just a bad test. It was an early warning. Now we need to talk about something even more dangerous than overheating. Expectation. Because this project was never built to fight at the back. It was built to make a statement. New facilities. New technical structure. Adrian Newey's influence shaping the aerodynamic philosophy. Honda returning with long-term commitment. Everything about this partnership signaled ambition. But preseason testing does not care about ambition. It cares about evidence. And the evidence so far is uncomfortable. The AMR26, when running restricted, shows flashes of aerodynamic efficiency. Even with temporary cooling cuts in the bodywork, the car looks stable in medium-speed corners. The balance does not appear chaotic, which suggests the chassis concept may actually have potential. But potential means nothing without full power. Because under modern regulations, energy deployment is not a bonus. It is the backbone of lap time. If the battery overheats during aggressive deployment cycles, the system protects itself. Power cuts. Clipping begins earlier. Acceleration flattens. And that creates a cascade effect. Lower straight-line speed means less overtaking potential, less defensive capability, more exposure under attack. But here is the deeper issue. When engineers cannot push full deployment in testing, they cannot validate race strategy models. They cannot simulate late-stint tire degradation accurately. They cannot test energy harvesting balance across an entire fuel load. Which means when the lights go out in Bahrain for the Grand Prix, Aston Martin could be guessing. And guessing at this level is costly. There is also a psychological ripple effect inside a team when reliability dominates conversation. Instead of discussing fine-tuning, instead of optimizing brake migration, instead of exploring aerodynamic balance shifts, meetings focus on survival, on preventing the next failure, on emergency fixes. That slows performance evolution. And in a season where competitors are already refining long runs, that delay compounds. But here is where this becomes even more serious. Honda's challenge is not only hardware. It is correlation. If factory simulations in Japan do not match real-world thermal behavior in Bahrain, engineers must recalibrate their entire modeling structure. Airflow predictions, heat rejection assumptions, energy density under sustained stress. That takes time. And time is the one thing preseason does not provide in abundance. The team now faces a brutal equation. Option 1. Open the bodywork further. Sacrifice aerodynamic efficiency. Guarantee cooling stability. Option 2. Keep the aggressive packaging. Risk recurring overheating. Hope software management can compensate. Neither option is ideal. Both are compromises. And that is why Bahrain testing feels like more than just a slow start. It feels like exposure. Because this was supposed to be a carefully synchronized partnership. Instead, the integration between chassis and power unit looks incomplete. And if this is the baseline before race 1, the competitive gap may widen quickly. Red Bull has reliability. Ferrari has momentum. McLaren has consistency. Aston Martin, right now, has uncertainty. And uncertainty in Formula 1 spreads fast. The final and most important question is this. Can Honda solve the battery instability, vibration concerns, and thermal management issues within days? Or will the opening Grand Prix become a live experiment under race conditions? Because if Bahrain testing has revealed anything, it is that the AMR26 is not yet ready for a championship conversation. And if Race 1 confirms these weaknesses, the narrative of this season may shift before it even truly begins.